let me make sure I have the chat window open. All right, so I think it's recording now. Okay, so let's kind of do a quick review of what we did. Then I'm gonna, excuse me, I'm gonna introduce a new instruction, and then we're gonna switch to downloading and installing the piece of software that allows us to write MIPS assembly. And then I'll kind of show you how you can do the things that we learned. And I think we're going to have time to talk about more instructions. So let's kind of do a quick review for the stuff that we covered, mainly the instruction that we covered last week. So we said you can do addition in MIPS, and the syntax looks like this. So if I were to kind of write the syntax in a more general way, I can say it's an add, and then there's a register, register, register. Or I can say register A, register B, register C. And the way this instruction is going to work is we're going to add the content of register B to the content of register C, and we're going to put the result in register A. So that kind of the syntax and the description is really enough. I mean, that tells you everything about the instruction and you can use it. So here we have an example. We have add S0, S1, S2, which means get me the content of S1, add it to the content of S2, and put the result in S0. And here I showed you another command in C, and I told you that this would actually be very similar to this if we assume that the content of B is already stored in S1 and the content of C is already stored in S2, and that we're going to put the result in S0. So we're going to treat kind of S0 as A here. If that's the case, then those two would do the same thing essentially. So if you want to assign the value of a register, or rather a value of a variable in C to another variable, if you want to do that in MIPS, then what you could do is you could get that register, or rather the register that contains the value of G in this case, and you can add 0 to it, and you can put it in as 0. So let's make sure that we know what's happening here. 0 is the name of a register. So again, after the $sign, we're going to put either the name or the number of the register. There's a register that has the name 0, which has the number 0. So you can do it like this, or you can do it like this, identical. So the name is 0 and the number is 0. And what's interesting about this register is that the content of it will always be 0. So this one is a register, is one of those 32 general purpose registers. The number of it is 0, meaning it's kind of the first one in the list. The name of it is 0. So that's easy to kind of remember. And also the content of it is 0. So you cannot even put a value in this one. Like even if you try to put a value in this register, it's not going to work. So in this case, we're getting the content of S1, which really we're assuming that is really the register that we're using for G, plus the content of 0, which is really 0. Essentially, we're adding nothing or 0 to G, and then we're putting it in S0. And here, if we were to assume that S0 is going to be really F, then that instruction, adding 0 to S1 and putting it in S0, is kind of the same thing as doing this in C. So this is really the example that we showed in the previous slide, and this is the new stuff on this slide. Do you have any questions about this? So the registers that we right now know is there's this one, 0, which means kind of, which has the name, not means, let's say, which has the name 0. And we also talked about the T0, T1 up to T7 and S0, S1 up to S7. So if you remember the numbers of those, it's really 8. So 8, which has the name, let me just say 8, which is T0, and then 9, which is T1, you know, so on and so forth. Let me just do that. And then we get to 16, which is S0. And then we have 17, which is S1. And again, you can continue up to S7. And we did say that it's easy to actually go from 16 to S0 because we can look at the two most significant bits in the 5-bit representation of the number. So if we were to put, let's use 17. If we were to put 17 in 5 bits, it would be 16, 0 for the 8, 0 for the 4, 0 for the 2, and 1 for the 1. So that would be 16 plus 1, and that would be 17. And if you see this one, and you want to convert that to the name, then you can look at the two most significant bits. That's going to tell you that it's an S register because it's 1, 0. And then you look at those 3 bits and you say, oh, that's a 1. So this one is S1. So that's kind of an easy way to convert from 17 to S1. We did talk about that last week. So if you feel that you need to, see a recap of that, you can watch the video. All right. So I'm going to continue. And now we want to talk about a second instruction. So this is sub for subtracting. And you can actually guess how the syntax is going to look like, and you can guess how kind of the operation is going to work. It's not going to be very difficult for you to do that. It looks like this: sub register. Let's just say, give it register A, register B, and register C. And this one's going to subtract C from B and put the result in A. So that one's going to subtract the value stored in, let's say, the value in register C from the content of register B, and it'll put the result in register A. So for example, if you say sub, say T3 S4 S5 or S6, then what's going to happen is you're going to subtract the value of S6 from the content of S4 or the value of S4, and you're going to put the result in T3. So it's kind of like saying T3 equals to S4 minus S6. So that's really how you would want to interpret this one. Now, one thing that you did not ask me, and I think is a good question, so I'm going to answer it anyway, which is, can we use the same registers in more than one location? And the answer is yes. So for example, you're allowed to do that. Now, of course, this one's going to subtract the value of S4 from S4. So you're going to end up with 0, and you're going to put 0 in T3. So this one's going to put 0 in T3. And you can even do this if you want. So let's say at the beginning, S4 is, let's say 100. What we're doing here is we're saying subtract 100 from 100. So we end up with a 0. And then you put that 0 in S4. So after executing this instruction, S4 is going to be 0. That's just an example. I mean, it's not an important one. It's just an example where we would kind of reuse some of those registers. Now, of course, you probably wouldn't want to do that. That's a weird way of giving the value or giving the register as for the value 0. You wouldn't want to do that. There's a better way to do it. Again, this will work, but it's kind of confusing. When someone reads it, they're going to be asking, why did you do it like this? Was there a specific reason you went about giving the value 0 to S4 like this? So we wouldn't want to do that. But at least if you see it, you know what that means. Let me pause here for a few seconds, see if you have any questions. All right, so that's good. No questions. And here we have another example. So let's look at this C code. D equals to E minus F. And again, if we assume that E corresponds to E corresponds to S4, F corresponds to S5, and D corresponds to S3, then this code is going to be essentially the same thing as this code in MIPS. So if I may give you this code in tomorrow's quiz and ask you to convert that to MIPS, and maybe I'll tell you for the variable E, use this register, for the variable F, use this register, and you would have to, give me the answer in MIPS. That's possible. In fact, I think I do have a question here, and I'd like you to think about it for a few seconds, maybe 1 minute. And I'd like someone to kind of try giving me kind of answers that are not necessarily complete, but maybe, I just want to hear your thoughts on this one. So I have this code in C, which, as you can see, it does multiple things. It adds B to C, then adds D, and then subtracts E, and it puts the result in A. And here, if I'm telling you that A corresponds to this register, B corresponds to this register, and C, D, E correspond to these registers, how can you convert that C to MIPS? So if I give you this question, here's the C, tell me how that should be written in MIPS. Think about that for, again, a few seconds, maybe 1 minute. And if you have any ideas, I want to hear them. All right, so Grace has an answer. Someone likes the answer. Anybody dislikes the answer or thinks that maybe it's not quite right? Okay, so Anthony is saying, can we have more than 3 registers in a single statement? No, you cannot. So you see the syntax that we looked at, sub register A, register B, register C. It has to be like this. So this is kind of a strict syntax that needs to be followed. So based on the answer that was provided, okay, so the answer has been changed. I'm going to copy the new one, paste it, and then we can look at it together. Let's do that. So let me actually paste it here. Let me duplicate this one. Actually, that's not what I wanted to do because that duplicated the entire slides. Let me delete copy here. Let me copy this one and paste it. And then let me take the answer and put it here. Okay, so that's the answer that was provided. So let's try to kind of look at it quickly. So what this line is going to do, it's going to take the content of S1, add it to the content of S2, and it'll put it in S0. So this is good because S1 is B and S2 is C. So it's going to essentially add B plus C, and it's going to put the result in A. So that's good. So you're essentially accumulating values in A. And then you're going to take A, right, S0 and A, which is A, and you're going to add to it S3, which is D. So that's great. So right now, S0, which is really A, is going to contain B plus C plus D. And then what you're doing at the end is you're saying, I want to subtract E. So I can get A, put it here, and I can say from that value, subtract this value, which is E, and put the result in A. And that's perfect. That's the correct answer. So this is the correct answer. All right, so let me see what I have here. I have a very similar answer. The only difference is instead of using A, which is S0, and kind of overriding the value of A 3 times, first putting this, and then putting that, and then subtracting E and putting the result, instead of doing that 3 times, what I'm doing here is I'm using a new register called T0. And I'm saying, let me add B plus C and put it in T0. And then after that, I'm saying, let me add D to it and put it in T0. And then what I'm saying here is, let me subtract E from T0, which contains all of that, and then put the result in A. So it's fine. Instead of overriding A multiple times, I decided to use kind of a temporary register, which is a T0. And yeah, so that's fine. Now, which answer is correct? They're both correct. Which answer is more correct? For me to answer this question, we would have to really talk about the distinctions between the T's and the S's, and we're not going to do that today. So T's tend to be for temporary, and S tends to be for permanent variables. But there's another more important kind of distinction that we're going to have to talk about later, because that one is going to be, it's not going to make sense to talk about it right now. But there is a clear distinction that we need to talk about at some point. And after you know that distinction, you will realize that in some cases, this answer would actually be better than the answer that was provided. But for now, this is perfectly correct. Okay, so let me go to the next slide. I think there's another instruction here. Okay, so we talked about add, we talked about sub, and now we want to talk about add immediate. So immediates, when you hear the term immediate, when we talk about MIPS, or rather assembly languages such as MIPS, immediates, they're numbers. So when you hear the term immediate, it's like a number that is literal. So something like 5 or 50 or 100 or 200. So this is really what an immediate is. So there's this instruction called add immediate. And essentially what it does is it adds an immediate. So immediates can be positive and they can be negatives. Either is fine. They can be 0 if you want, that's fine. But this instruction add immediate is going to add an immediate to a register, and it's going to put the result in a register. So let me add this one here. So it looks like this, ADDI. So there's this I that distinguishes it from add. And the syntax looks like this: register A, register B, and here we have an immediate. So for example, something that looks like this, T0, T4 is 0. This is incorrect. This is incorrect syntax because I'm using add immediate and I'm putting a register here. So that would be wrong immediately. So it would have to look like this: add immediate, some register, say for example T0, and then T4 possibly, and then some immediate, which could be 20 or negative 30. It could be any number that you want. That would be the correct syntax. And the way this instruction works is we're going to get the content of a T4. We're going to add to it this one. So in this case, when you add negative 30, it's almost like you're subtracting 30 from it, and you're going to put the result in T0. So if the value of T4 is, say for example, 20, then after executing the instruction above, the value of T0 is going to be negative 10. Let me just do that. Because it's, again, you have 20 here and you added negative 30 to it, you end up with negative 1, and that of course goes to T0. All right, do you have any questions before I show you how to download the piece of software that's going to allow us to run MIPS code? And we can just start writing code there. But do you have any questions? Let me pause here for a few seconds. All right, so I think you don't have any questions. So what I'm going to do is I'm going to stop the recording, and then I'm going to start a new one, and then I'm going to show you how to download this piece of software, which is really a simulator. Let me stop recording.